So our next finalist is Lindsey Remark from NYU Grossman School of Medicine, and she'll be presenting Dissecting the Molecular Mechanisms that Govern Notch-Mediated Skeletal Stem Cell Maintenance Throughout Adulthood and Aging. Right, Lindsey, whenever you're ready.
As I walked down the street the other day, I couldn't help but notice all the store ads aimed at slowing or reversing the aging process. Try this anti-aging skin cream to look 10 years younger. Try this supplement to restore your youthful metabolism. As far back as the 5th century BC, when Herodotus told stories of a fountain of youth, people have been fascinated by finding eternal youth, as the aging process erodes at your ability to fully enjoy life. Bones are hit especially hard by the aging process. Orthopedic injuries are a leading cause of mortality and decreased quality of life in the elderly. In young, healthy bone, when a fracture occurs, skeletal stem and progenitor cells, known as SSPCs, proliferate and then differentiate to form new osteoblasts to completely heal the bone, as you can see in the x-rays of a 25-year-old patient at the top left whose clavicle fracture successfully healed after surgery. However, our group and others have shown that with aging, the SSPC pool declines and becomes dysfunctional. Therefore, the formation of new osteoblasts to heal the fracture is insufficient for proper repair, exemplified by the humeral fracture shown in the bottom left from an 80-year-old patient. In the Loish lab, we're interested in why SSPCs decline with age to understand how we can harness skeletal stem cells to improve bone regeneration. How can we find the fountain of youth for bone so people can live longer, more healthier, functional lives? Previous studies and our own data suggest that notch signaling plays a pivotal role in maintaining SSPCs. We have a mouse model where notch signaling is depleted in leptin-positive SSPCs. With aging, we found increased trabecular bone formation as a result of premature SSPC differentiation, as seen in the micro-CT images on the top right. And while this may appear advantageous, we believe this may actually be inhibiting healing because their SSPCs have already been differentiated. We use bulk RNA sequencing to identify the transcription factor EBF3 as a novel target of the notch pathway that keeps SSPCs in an undifferentiated state. In a series of experiments, we confirm that EBF3 expression is notch dependent, as shown in the graphs on the bottom right. We also have RNA sequencing data showing that middle-aged mice show less notch and EBF3 expression than young mice, which has not been previously described. This suggests that notch is necessary for SSPC maintenance, and as notch and EBF3 expression declines with age, SSPC maintenance is compromised. A balance needs to be upheld between maintenance and differentiation for proper fracture healing. We believe the notch EBF3 axis could control this balance and could be the fountain of youth we've been searching for. Thank you.
Wonderful. Thank you, Lindsey. Does anybody have a question for Lindsey? A couple seconds for people to type. Here's one. Okay, so what kind of potential therapeutic could be derived from this?
Yeah, thank you. I think that's a great question. Definitely where we want to go with this project. And I think the types of therapeutics that could be derived is some type of notch, either inhibitor or activator, depending on the stage of fracture healing. So obviously you want notch to be active at the beginning of healing when you want your SSPCs to be in greater numbers so that they can proliferate and that you can have enough substrate for differentiation of osteoblasts, but you don't want this to go too long because then you won't have differentiation can occur because as I've told you, notch is important in keeping these cells in an undifferentiated state. So you could imagine some type of notch activator being given, before surgery or even EBF3 as maybe you could target the transcription factor instead. And we're also looking for other members of this pathway. So you can have even more targets, which greatly increases your chance of finding a therapeutic. So we're hoping for something where you could, activate this early on, and then you can either use a notch inhibitor so you can get differentiation to ensue, or an EBF3 inhibitor later on when you want differentiation to occur.
Excellent. Thank you so much, Lindsey.